Hello everyone, welcome to another video of my channel. Today I'd like to discuss on a very important problem named coin change, and I'd like to solve this problem using dynamic programming approach. Let's see what does this problem say. It says you're given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. That means we'll be given an array which contain different coins of certain values, and we will be given another amount. Maybe you can call it as a target amount, and what we will have to do is return the fewest number of coins that you need to make up the amount. If the amount of money cannot be made up by any combination of these coins, return -1. You may assume that you have an infinite number of each kind of coin. That means we can repeat the coins. We can repeat a single coin. We can take the coin as many times as we want. So let's see an example. Here we are given a coins having an array, and the values are 1, 2, and 5. And our amount is 11. Within the fewest number of coins, what is the fewest number of coins we can take to match this amount? We can do it with 3 coins. That means 5, 5, and 1. We can make it 11. This is the fewest number. We can make it with another combinations, but that will not yield us the fewest numbers for sure. In example 2, we can see that our coins array contain a single coin having value 2 and our amount is 3. Seeing this example, we can very well say that this is not possible. So our output will be -1, because using only 2 we cannot make 3. And the last example, we can see that our coins has only one coin, a coin of value 1, and amount is 0. So this is also not possible. So our output here will be 0, because since our amount is 0, we do not need to take any coin, rather we take the 0. Now let's try to solve the problem at first. After that, using the solution approach, we will try to find out the programming solution. Here is a given example. We have an array of coins containing 1, 2, and 5. That means we have infinite number of coin with value 1, with value 2, and value 5. What we need to do is we will have to make an amount 11 using the minimum number of these coins. So as I have said, I'm solving this problem using dynamic approach. How are we gonna solve? What we can do is we can take an array or a 2D array of DP like this. Now the thing is that what will be the number of rows and columns of this very 2D array? The number of rows will be the number of coins, or simply the size of the coins array plus 1. That means this. So we'll have the values here like this. At first 0, this 0 is taken just to satisfy the base conditions, and the other values 1, 2, 5. One thing to mention is that here we are not taking the consecutive numbers, rather we are taking the values of this very coins array. And what will be the number of columns? The number of columns will be the amount plus 1, that is this, from 0 to the amount. So there will be, for this very array, there will be 12 columns. Now at first we need to satisfy our base case, and after that, using the recurrence relation, we will try to fill up all the cells of this very table, and at the very last cell we will get our required answer. Now let's see how we are gonna solve it. If we talk about the base cases, let's see if we do not have any element in the coin array. That means we simply have this 0. So in that case, will it be possible for us to achieve these targets? This won't be possible. That means there we will have infinite number of coins to achieve these targets, because we don't have any. So I'm gonna fill up the very first row with the, say, a number maybe int max, because we do not have any coin here. So we need infinite number of coins to fill this target. Now what about this column? Here what we can say, that here our target is 0. That means we need to achieve an amount of 0. When our target is 0, do we need any coins to fill that up? Not at all. So for this very cell, initially we do not need any coins to fill this up because we are already at 0. So this column will be 0. Thus, we have satisfied or completed our base cases. Now we need to fill the rest of these cells. Thus, while filling these cells, we'll try to find out our recurrence relation. Let's start at this very cell. Since we are at this very cell, what does this cell indicate? It indicates that we need to achieve an amount, a target amount of 1 using a coin having value 1. We can simply achieve it taking a value of coin 1 time. That means if I write here 1, I will simply achieve this amount. Similarly, what about the other cells of this row? What about 2? We need a coin of value 1 twice to fill this 2. Similarly, thrice to fill this 3, 4 times to fill this 4, and 11 times to fill this target amount 11. That means our this very row having 1 as its coin in the coin value will have these values, which is pretty straightforward. Now we go to our this very cell. In this cell, my target amount is 1 and my available coins are here 1 and 2. Now one thing to mention is here my target amount is less than my one of my available coins. So it is impossible to achieve the target amount with this very coin. So we simply take the coin of value 1 once to fill this very cell. That means we simply copy this value to here. Now what about this cell? Here my target amount is 2. I have available both 1 and 2. How can I achieve this 2? I can take 1 coins to fill this cell to make it as 2 target 2, or we can take this coin having value 2 once. So what is the optimum? What is the minimum? Taking 2 coin value having 1 twice or taking a coin having value 2 once? Definitely here minimum will be this one. Now how can I find it using this table? Have a look at the index number here. Here our index is 2 and here our coin value is 2. So we can subtract this coin value from this index and see that very particular cell. If we subtract 2 from 2, we get 0. In this 0 cell, what we have? We have 0, and we simply add 1 with this value and get our expected result, that is 1. Now we are at this cell. Here our target is 3. That means we can take this value here, or we can subtract this 2 from this index. That means we get 1, and we take this value plus 1. That means 2. So what is the minimum between 3 and 2? Is 2. And if we think about is in normal cases, if we take 3, that means we can take 3 1 coins, or we can take 1 2 coins and 1 1 coins. That means 2. 2 is our minimum and expected value in this cell. Similarly, in this cell, we can either put the value 4 or we can subtract 2 from 4, and we come to this particular cell where we have 1. We add 1 with 1, that means we get 2. So the minimum between 2 and 4 is 2. That means we have 2. Now for this cell, either we can take 5 or we can subtract 2 from 5 and go to the 3 index, and the corresponding value here is 2, and add 1 with it. That means we get 3. Minimum between 5 and 3 is 3. Similarly, if we think about this very cell, what will be our minimum between 6 and 6 minus 2, that means 4. Here 2 plus 1, that means here we will have 3. Now for these two cell, in this cell we will take the minimum of 7, or 7 minus 2 means 5. Here 3 plus 1, the minimum between 7 and 4 is 4. We will have 4 here. Similarly, in this cell we will have the minimum between 8 and 8 minus 2, that means 6. In this index we have 3, that means 3 plus 1, that means 4. The minimum between 8 and 4 is 4. For the next two cell, suppose in this cell we will have either 9 or 9 minus 2 means 7. Here we have 4 plus 1, that means 5. The minimum between 9 and 5. And here the minimum between 10 and 5. So in both the cell we will have 5. Now what about this cell? In this cell we can take 11 That means we can achieve 11 by taking 11 numbers of a coin having value 1, or we can subtract these 2 from 11 and come to this index. The value in this index is 5. We add 1 with it, that means we get 6, which means we can take 5 2 coins and a single 1 coins, which makes 6. So 6 here will be 6, which is our minimum between, which is the minimum between 11 and 6. Now for the last row, here we have got another coin of value 5. Think about all these 4 cells. In all these 4 cells, the target is less than 5. So we can certainly say that using a coin of value 5, we can never achieve this target. So simply we will copy these available values in these fields, because we don't have any other options here. Now in this very cell, our target is 5. We have available coins of value 1, 2 and 5. What is the minimum number of coin to take so that we can make it 5? The minimum number is 1, because we have already a coin having value 5. So here the value will be 1. Also, how are we getting this 1 from this calculation? We simply subtracting 5 from this index and getting 0th index, and at this index my available value is 0. We are adding 1 with it, and we are comparing the above value with the result. That means the minimum between 3 and 1 is 1. Now at this cell we will take the minimum of 3, or 6 minus 5, that means 1. Here we have 1. We add 1 with this value, that means we get 2. The minimum between 3 and 2 is 2. And if we also think about this cell, we will take the minimum between 7, and 7 minus 5 means 2. That means 1. 1 plus 1, that means 2. The minimum between 4 and 2 is also 2. So in these two cells we will have 2. Now what about these two cells? Here we can have either 4 or 8 minus 5, that means 3. Here 2 plus 1, that means 3. That means we will have the minimum between 4 and 3, which is 3. In this cell we can take 5 or 9 minus 5, that means 4. 2 plus 1, that means 3. The minimum between 5 and 3 is 3, which means that in these two cells we will have 3. Now we are at this cell, we can take either 5 or 10 minus 5 means 1 plus 1, that means 2. So here we'll have 2. Now we are at the last cell. The value at this cell will indicate our required answer. We can take either 6, or subtracting 5 from 11 gives us 6. The value at here is 2. We have to add 1 with this 2, that means 3. The minimum between 6 and 3 is 3. So 3 is going to be our final answer. And if we think normally, in order to make 11, we can make it using 2 5 coins and 1 coin. That means 5 plus 5 plus 1, that means we are getting 11. This is the smallest amount of coins we can take to achieve the targeted amount. Thus we solve this problem, and let's have a look at the key points we found from this solution approach. That means we need to initialize the very first rows and columns. We will be skipping those cells where the coin is greater than the amount, and simply what we did, we simply take the value from the above cell, and for other cells we had to find the minimum between the value of the cell which is right above that cell and the cell which we obtained by subtracting the coin values from that corresponding index and adding 1 with that value, and at last the very last cell gave us the answer. Now we try to solve this problem in Leetcode. Here I have written a solution of the coin change problem using the approach I just discussed. Now let's run it. So here we can see we got a success, and our solution is faster than almost 86% of other solution, and memory usage is less than almost 90% of other solution. That's it for today. I hope you have understood the solution approach of this very problem. I will be giving the link of this very solution along with this problem in the description section. Thank you very much.